All right, we're finally ready. Thanks for your patience. I'm gonna probably have to go quick through this. So this is Internet of Thingies. I hope that's why you came. Maybe you're hoping you didn't come. So the motivations for this is I work a lot at home, so I was being more aware of energy use and heating and cooling and just the environment I was in. So I work for a monitoring, open source monitoring software project, and so I'm very acutely aware of data and working with data and analyzing and things like that. So I was motivated to come up with better ways of understanding my environment and making it better. And so that's what drove exploration into what I'm about to show you. So your typical home, smart home diagrams kind of thing. Look, there's a ton of these, and I just picked a few, and they look something like this, and they get complicated. Looks like this might go off the side of the screen a little. This is another one, usually multiple connected things, feeding information into a hub, and then you have some controllability too. This is one I really like, but I don't speak Russian or read Russian, so I don't know what it says, but it's pretty awesome. I like it because there's a lot to it, so one day I'll decode it. Going further, you know, you get extortion and nagging and things like this. That you can kind of see this coming maybe with AI and more connected things. So it may not be ideal. And then finally the machines take over and ruin your life. And we live in the Matrix or something. Okay, so that's my doomsday kind of view on it. But back to reality. So I had some design goals. I work for an open source project, like I mentioned, and so I want the solution to be open. I want it to use normal protocols that have some flexibility. I don't want it to be super expensive. I want it to be able to communicate over IP because that's a kind of a common mechanism to communicate. So this was like my starting point. So when you start making things, you need a good workspace, and this is not one. This is where I started at my kitchen table, and it's not ideal at all. Since then, of course, like any good inventor, I moved to the basement and made a little bit better workspace. So there's more there than you need, but I found having lots of flexibility and variety sparks creative juices, so it's a good.
You need it.
Okay. Tools are very important. The takeaway I've had so far with tools is quality lets you enjoy and work better. And so if you can, it's often worth doing good research and spending some money on the tools. For example, my example here is this little bendy arm thing is a combo magnifying glass. It's got a little LED. It also has a base. And it's got a clamp, so you can clamp it on the edge of something, but it also has a base that folds away. And so normally what you have with these holder things is like this rod with alligator clip things to hold when you're soldering or doing anything. And it's a horrible little tool, but it's the one you find everywhere. So I found this on Amazon for, I don't know, 20 or so bucks, and it's been a nice little addition. Things like variable power supply, just all these little things they're not required, but they help. They make what you do go much faster and give you flexibility that you would struggle to sort of wedge things under to get just right if you're soldering things. So spend time with thinking about how you're set up and ways that you can improve it. This again, this power supply is like a $30 or $35 power supply. It's not super powerful, but it goes from I don't know, 0 to 24 volts ish, and delivers like 6 amps. And it's a nice, fine controlled tool. So that makes working with little electronic things easier. It's just instead of trying to get the right voltage or regulate to a voltage level you need, like things like tools like this make it a little bit easier. And there's my cursed laptop that's right there. So here's kind of a real basic list. This will be in slides, so you can reference this later if you need, but really basic stuff. Small screwdrivers are maybe overlooked, but just a cheap jeweler's screwdrivers kind of set does it. Any voltmeter, you can spend money on more expensive stuff like a Fluke or something, but working in this realm, you don't need super expensive things. So this project that I'll talk about is just simply making a temperature sensor and collecting the data and analyzing the data. So I started looking at Arduino as a way to do this. This is an image of a few different sensors, and I've got just a board with a few of those here as well. They have different characteristics, and they all cost about 10 bucks or less. Just the sensor, just the temperature sensor. Here are different properties of those sensors, and this is important because what you end up doing, you kind of have to find your way through this maze of specs to either having to adjust to what you're working with, or drop off some other kind of priority you've got for your project. So I would guess right now there are at least 30 plus temperature sensors out on the market in independent sources and wider production kinds of products. So you have unfortunately, a huge variety of these things. So you have to kind of get to understand why some things are better than others. If you're working to measure the temperature in a keg of beer or your brewing process in your basement, then you probably need a waterproof one. So things like that you have to consider along the way. They're not difficult decisions, it's just you have to be aware of this stuff. So Arduino, so raise a hand who knows what or has heard of an Arduino. Okay, and then put your hands down, and honestly, who has not heard of Arduino in this room? So nobody. Okay, one. Perfect. Thank you. So anyways, they're a general purpose programming board. They have digital and analog inputs and outputs. Yeah, I know. You can program it over USB. It's got a variety of voltages it'll work with for input voltage and what it'll output to sensors. And it comes in, I don't know, there must be 50 varieties of Arduino or related kinds of boards from different manufacturers and different builds out there. So that was the first thing I looked at. Arduino's got integrated developer environment, so it's got an all-in-one tool that you can interact with the boards and program and get feedback in a console. So looking at IP communications, that had the option of put an Ethernet shield on it to speak Ethernet, add libraries to work with. What kinds of ways could I get data out of it in terms of does it have for example, an SNMP library for network metric or network management protocol networks? Does it have a web server capability? All these other kinds of things. How can I work with the equipment I've got to get data out that I needed? So, who's heard of ESP8266? Okay, so that's a lot fewer hands, and so this is what I ended up landing on. So they're cheap. This is the Rev 01 of this chip, this little one that I'm showing. It's got digital and analog inputs and outputs, USB programming. So similar to Arduino in kind of capabilities, it doesn't have as much flexibility as an Arduino does. And it also comes in 20 or 30 now. I mean, this kind of chip this board is exploding in what's being released and the varieties of it and various development boards. So this, I looked at this and thought this is could be a great way in. So it's got built-in Wi-Fi, it's got a built-in TCP/IP stack, it's got a built-in web server. So that eliminates a whole bunch of requirements that you'd have to put in Arduino to make any of this go. Very attractive, and that one was $5. So I built a prototype. And again, in the details, like I make a note about just a simple thing like voltage regulation. So this thing works at 3.3 volts, so you need whatever your input voltage is, like if it's 12 volts or 6 volts, you have to regulate it down to 3.3. And so the danger here is that with a simple regulator, if you don't have a heat sink on it and you're giving it 12 volts and you need to drop it to 3, it's going to burn up that regulator. So you need to know that it needs a heat sink. So all these details can make a difference. And when you're exploring and working with these things, it's important. The worst you can do, though, is you burn up a $5 chip. So order in quantity or small quantity, because for that and other reasons. But I got it working. I had it output a little web page. I can collect data from that. You know, all is good, right? So that was the first round of this. And then I wanted to simplify and improve on some of these things. So first of all, this is not an energy efficient solution. The web queries, if I'm doing regular data collection, has an energy cost. And I found that for AA rechargeables, which are at a lower voltage than a regular alkaline batteries, they don't last. They almost last a day, but not quite. That's just a 5-minute web query to get that data out of it. So there's other ways you can approach this and save a lot of energy. Also, this was a weird fitting. The way they had the pinouts on this little thing was a weird fitting pinout, so that it couldn't bridge. Can't point to it, but so you have a breadboard like this, and the pins can't bridge the gap in the breadboard because you have pins on one side that deal with power and ground, and on the other might have some I/O kinds of pins. So you have to have a way for that to work on a breadboard. So I got this little adapter, but then the output pins on it were too small to fit into the breadboard. They weren't the same kind of pin layout. So I just clamped it with a battery clamp to the board so that it stuck and made contact electrically, which sucks, right? Because this is all hokey now. So I went further, and the bottom picture is showing me squeezing up. I heated up, squeeze up pins, and then soldered on like a 90-degree pin so that it could span the breadboard and then fit kind of natively in there, right? Still hokey. But this is what, right? You go through iterations on this. The other thing about this is you have like a voltage regulator, so you have an external component that could fail in and of itself, and you have more complexity in wiring, and where all your failure points you're increasing. So want to minimize that. I also want to have just one thing that's cheaper than the sum of all the cost of the other components. So I moved on to, and if you look at this one, it's the ESP12 revision of the ESP chip. So I went to this, which is a more encompassing chip. It's $10 instead of $5, but it's got a built-in regulator, so I don't have to worry about voltage regulation so much. Has more inputs and outputs. It has reset and flash for firmware programming. Has these switches built in, so you can reset the device on the device, or you can load a new firmware and put it into loading kind of mode. And this one that's sold by Adafruit comes with it's called a Node MCU firmware. I'll get into that a little bit, but that's built on, and it's a Lua scripting language-based firmware, and I'll get into that too. So there are many tools out there freely available that you can use to load firmware. So one is the Node MCU's flasher utility. There's a link to it. You can use the Arduino native IDE to load firmwares, and there's one I found recently called ESP Tool, which is a Python-based bootloader. The firmware is available. These are growing too. Node MCU, like I talked about, is a Lua scripting language-based firmware. There's I've recently found this Mongoose firmware, and it's JavaScript-based. So if you want to write your application in all JavaScript, you've got a firmware available. ESP Easy is interesting because it has a web interface built in that lets you select and control things on your chip, so that can be less programming involved and more clicks kind of through a web interface. So that's an interesting one. There's an Arduino firmware, but I've seen a couple things. One implies using the ESP-easy firmware that's got that web interface, and then there's another one on GitHub that lets you use the Arduino developer environment to program it. So there's a couple of varieties, and I haven't worked with them, so I don't know the differences between them. And finally, this is new. Well, 2 days ago was announced an integration to one of the developer environments, but this MicroPython there's a new iteration that started at the first of the year that was kickstarted, and it's basically a MicroPython implementation that is a firmware implementation for this chip and other chips too, but this one seems to be the popular one in this kind of realm. So anyways, you could write a full you could write your apps in Python. So that's 5, and that gives you a lot of variety, flexibility of what you can do. You know, what your capability, what your comfort level with different languages, things like that. You have a lot of options. It's only because this chip is so friggin' popular. Here's the so this is it's called ESplorer, which is ESP Explorer IDE, and what it will show is basically the MicroPython integration with the development tool. Gives you a Python console and gives you a thing to write your code, a little editor, and then controls of sending the code to the ESP8266. So again, I chose Node MCU's Lua-based firmware. It's got a lot of flexibility. So here's a little bit about Lua. It's a lightweight, kind of scripty language, but it's a programming language for embedded systems. That was why it was developed. I'm just going to read through this. Lua is on a lot of applications and video games. So Adobe Lightroom, Apache HTTP server, Cisco security boxes, on and on and on. Lots of different things make use of Lua. Here's some video games. Some may be familiar to you. It's fairly widespread, so that's another positive in my mind, is that it's common enough that I can get information, maybe support, understanding for things that I'm doing, because there's a pretty broad community out there that works with Lua. This is the Explorer IDE. Again, I showed it to you with the Python integration slide, but basically it's got the editor, it's got a console, and it's got controls for sending code to the device, and it's got controls for manipulating files that are on the device, because there is sort of a mini built-in file system in this firmware. Kind of a small feature I'm showing here is that this Lua code can be further compiled and optimized so that it's a smaller package, because these things don't have endless memory and storage. So there is an option on here to compile and basically makes the code more efficient and still runnable on the device. Here is, let's hope this stays up. This is sort of one version of the code I used. So I set up the wireless stuff at the top. I had a really hard time figuring out how to do a static IP address on this thing, because the idea is I'm using a lot of these sensors spread throughout my house, and I need to data collect from them, so I can't easily, you can make it work, but I can't easily have DHCP addresses because I don't know which thing's which. I want to set a plan for my addressing and reliably get to the device to collect the data I want, and know that this device is outside and this one's in the garage and this one's in the attic or the basement or a living room or something like that. So it was a struggle finding out how to do static IP address, but I figured it out, got it working. Basically some pin definitions and some variable definitions. It runs a function to read the data from the sensor. This thing with the alarm is basically a 30-second reads loop. and then I take the data I collected and output it into a web page. Very simple. You can get way more complicated, but again, my goals were simplicity and kind of a normal way of getting this data. You could output with XML or any other kind of mechanism you can come up with. I've been working on a project where I wanted to send out syslog. So there's just how there is a web server kind of setup. There's a UDP service that's built into the stack. So I can enable that and send out UDP messages on the syslog port 514. So super flexible ways that you can work with these things and build what you need out of them. The thing that I'm working with is more of a control. It's a motion sensor for controlling lights. So I wanted to know when the lights are on and when the lights are off. So that's my simple way of doing it, is sending a message every time that happens, so that I can record the time in between and then record how the length of duration that lights were on, and then derive energy use based on that, and see how that changes, whether automation makes it more efficient or just flipping the light off and on is a more energy efficient way. But this is kind of how I think about these things, is how can I measure something to understand something better. So now we'll flip to the sort of software side of this. What do I do with the data? I work for the OpenNMS group. We're the project maintainer for an open source project that's enterprise monitoring. We've been around for 16 years or so. The quick spiel is, and this is not a sales thing, I'm just trying to explain what it is. We have like a Red Hat Fedora kind of model where we have a long-term release to a private repo that companies like to subscribe to. But we also have a community version. The code is the same between the two. We've found that sometimes companies like paying for software, so we give them a way to do that. And since it's a slower release cycle, year to a year and a half between releases, that's less disruptive for a corporation. The community version gets newer features quicker. It's a 3 to 4 month release cycle, so it lets people use the latest and greatest features and code and bug fixes that we put in. So that's the quick spiel on it. We also have a mobile app, which is the little arrow in the center, if you guys ever see that again. Here it comes. So the little arrow is our symbol for our Compass app. This is not really important, but basically in OpenNMS, this is the configuration for getting a sensor into OpenNMS to be monitored and data collected. So I'm just going to breeze through this. This is also the data collection setup. A lot of our configs are in XML, so it might look funny to you if you're not used to looking at XML. So it's just basically data. This is the data collection setup, collecting the metrics, and it's doing it by parsing the web page that the little sensor made. So, and what you end up with is, right, from a simplistic view is just graphs of your data, right, showing over a week what's been going on, humidity and temperature. You know, the humidity data might not be there if your sensor doesn't support humidity reading. It could be barometric pressure. It could be some other sensors built onto that, or data built onto that sensor. Then in terms of analysis, so what I was looking at here is we had a hot spell a couple weeks ago, and it got up to 89, I think. Yeah. And so I was curious, if I have a window fan in the kitchen, does it matter if I turn that on at night to blow cold air in? And so the first two graphs are with the fan on, and this one is with it off. And there's no real, other than that little ledge coming down over there, which could be anomalous, could just be something that happened outside in the temperatures. There doesn't seem to be a big difference between turning on a fan at night and just letting ambient catch up. Now this is in Oregon, in the environment I'm in, so maybe, you know, that changes based on location where you live. So, but this is the kind of thing that I'm really interested in. It's like, do I waste the energy with fans on, or leave it alone and just let nature cool down the house? And now that I've got data, I can see whether it makes a difference and save energy or not. So that's interesting to me. The next one that may come up is with the tool, we also have an API that lets you use multiple types of data store for time series data, and also lets you send that data out to various display graphing technologies, however you want to do it. Send it to a database, send it to a graphing library, whatever you need. And so here it comes. So we have one that's a Grafana plugin. So you get overlaid data from different sources, which you can't do with the older RD based, which, you know, that's like a tease. You just got to see a brief second of it. So it's much prettier. Holy cow. It's a nicer looking display. It's more flexible in that also there's built-in thresholds, so you can color the numbers based upon it reaching thresholds, so you can visually see quickly. I didn't include a slide, but you guys heard of Conky? It's a desktop overlay that you can show live metrics of your system and other things. So I also integrated these data in a Conky display, so I can basically see live readings of all the sensors I've got spread around, just so I can see a quick comparative thing, like, hey, it's warmer outside than it is inside, so open the windows or close the windows or do whatever your kind of thing is. But that was easy to, it's basically still parsing a web page, which is part of the goals, easy to get to the data, easy to work with the data, and make use of it. So now I have multiple ways of working with this stuff, whether it's complicated like this or whether it's just a simple Conky display. This is just more of that dashboard. The big one showing barometric pressure, and then the bottom little ones are each sensor and their particular. So, yeah. This is it. This is the game, right? There's pain involved, but because they're relatively cheap, it's not a huge impacting pain, and you learn from it. The best thing to do is to fail so that you learn something from what you're working with. So these are kind of my tips from my experience. I have a lot to do. I have other more efficient collection means for the energy efficiency of the device. You can do push collections from them, and by doing that you can bring it up quickly, send out a metric, and drop it into a deep sleep mode, and that'll extend battery use to like months, if not years, kind of a thing. I don't have that set up yet, but that's one that I'm working on. I need to compare different sensors, so this is the ESP8266 I'm working with, and then this is a temperature humidity. This is a waterproof temperature, and then this is another temperature and pressure sensor. So I'm building this to compare the three together to see how far apart they are and how far apart they are from the other sensors I've already got set up. I've got OpenHab. If you've heard of that, it's an open source hub basically for smart home type of a setup. I've got that running, and I'm working to build that out more, maybe for Talk version 2 with a good slide setup, reliable slide setup, and more thingies. So I talked about it before, but these chips are kind of exploding in popularity and varieties and what people are making. So here's one that has now instead of this one that I'm working with has pins for your USB connector, so you have to buy kind of a USB console cable and connect to the pins. This one's super easy. It's just a micro USB connector, and it's got a connector for a LiPo battery. This is from Adafruit. They came out with it. I think it's $15. And of course, SparkFun, which is sort of a major manufacturer of these things with Adafruit, they can't be left behind, right? So they're showing the same kind of thing, and they've got a little solar panel connected so that you never run out of energy with your device, right? It's eternal. Here's the Arduino. I don't think I talked about this, but basically Arduino made Arduino's got the Uno board, and if this slide shows, it's basically, they basically integrated an ESP8266 Wi-Fi chip into it to make a Wi-Fi Arduino board. And there it is. Briefly, get your glance while you can. And finally, never go to Tindie, because here's my wish list, and this is like maybe a third of it. This is what, you know, who needs a Doppler speed sensor? Who needs a Geiger counter kit? But look at how cool that is, right? Don't you want to make that now? Because you can make it. And look at all these cool, this is the old Texas Instrument red LED from the old calculators, right? You can buy these things. They're kind of expensive, 40 bucks for that, because they don't make them anymore, so price will only increase. But you have, and then I probably have like 10 at least different temperature or humidity or other thing kinds of sensors on this list too. But like someday I'll get to these and play with them and see what I can do. But this side is good in that it kind of fuels imagination. So it's
you need the Geiger counter to seed your random number generator.
Okay. I want to go, because I go explore in the boonies, and I've come across like Madame Curie's old uranium encampment where she basically did all the research work to get the Nobel Prize. So now I want to build that and go out there and see if it's, you know, there's still heavy radiation readings that go on. But anyways, that's a very specific use case. So here's me. I'm embarrassed to say that my GitHub is pretty sparse and lame, so don't go there. But you can get to me in other ways. I'm happy to answer questions, you know, through email or whatever, and these are just ways of finding me. Any questions? Did we run way over?
Nope.
Okay. When's this supposed to end? At half past?
8 minutes.
Okay. So, any questions? Sure.
XML, what's your advantage for using XML?
XML in general is so it's built to be human and machine readable code, so it lets you operate flexibly that way. You can understand it once you're used to looking at it, and machines are built to understand it, interpret it, and use it. So that's the big advantage. Yeah.
How did you measure the energy usage for the HTTP request and like calculate like that?
I had a well, so there was so I had to guess. I saw it written up that way, and then I also was able to measure it with the current.
Okay, so you have a current monitor.
Yeah, there's you can get little DC current monitor and collectors, and then collect that data too. I didn't show any of that because this was already. So I'm working on that as well to do more energy measurement and monitoring at home, you know, in a broader, so I can determine what's using a lot of energy. I have kilowatts sprinkled throughout the house too to figure things out. Yeah.
So do you put these chips in some sort of encasing if you're putting them outside?
Yes.
Is there just common ones out there that are recommended?
Not really. People do a lot of 3D printing for cases. But also you can get electrical panel boxes that are just for like outside outlets from Home Depot or something, and you could use that and stick one in there. So yeah. Yeah. I'd start with this little thing because it's fairly flexible. There's a lot more material out there for Arduino, and so that could be a starting thing too. The problem is a lot of examples are how to make an LED blink, and how to. So one of my requirements was I want to keep the data locally for my use. A lot of the examples are send it out to this cloud service and go look at the graph out there, kind of a thing. And I didn't want that either. But those are the kind of examples you're going to find out there. But it's very doable. There are starter kits. There are all kinds of things for this.